Hey guys, welcome to, what is this, week 2/3 of virtual learning, week 4 of quarantine. I hope you all are surviving and making it okay. If you are bored or lonely, see you at some of my online office hours maybe. Alright, so assignment 3. This is about graphical analysis, so like the latter half of fall semester. Some information that we need to remember in order to answer these questions. So first of all, when we're talking about like algebraically from an equation, if we want to find where the graph is increasing or decreasing or where they have relative max or mins, you need to know about f primes. You need to make an f prime number line. If you're asked about concavity, is it concave up or down, or about a point of inflection, then you need to know about f double prime, so make an f double prime number line. Your justification for each of these, my handwriting's gotten like even worse. Your justification for f increasing is that f prime is positive. If f is decreasing, f prime is negative. For a relative maximum, we know that f prime changes from positive to negative. Yeah, because this relative minimum, f prime changes from negative to positive. For concavity, if f is concave up, there's two things. You could say f double prime is positive and concave down, right? F double prime is negative. But you also can say, or f prime, if f double prime is positive, that means f prime must be increasing. And f double prime negative means f prime or f prime is decreasing. So I'm going to just make the little table real quick. So this is f prime, this is f double prime. Get another. If f is increasing, decreasing, concave up, concave down. This is positive, this is negative, don't know anything. This is positive, this is negative, and then it's like the same thing, just shifted, so increasing and decreasing. If you're wondering what that table looks like. All right, and lastly, a point of inflection. So point of inflection is where f double prime changes signs, or f double prime changing signs means f prime is changing creasings. F prime changes creasings. And don't actually write changes creasings. Say like from increasing to decreasing or decreasing to increasing. All right, a couple things to point out. Where f is increasing or decreasing, that is going to be an interval. So like from this x value to this x value, right? That's not going to be at a point. It will be an interval. A relative max or min, that will be at a point. So x equals 2, not an interval. Concave up or down, that will be an interval, right? From this point to this point, it is concave up. And point of inflection, obviously, will be a point. All right, so number 1, we have a graph of f prime, and I am looking for, I'm looking for all x values where f has a point of inflection. So for a point of inflection, we know f double prime changes signs, but I have a graph of f prime, so let's look at our f prime justification. F prime changes creasing. So I'm going to write because f prime changes from increasing to decreasing, or it also could be f prime changes from decreasing to increasing. So I went straight from my question to my justification because my justification is going to tell me exactly what to look for. So I'll just sketch a kind of a graph like this. All right, so now I'm looking at my graph. This is f prime. I'm looking for where f prime changes from increasing to decreasing, or decreasing to increasing. So let's look. Decreasing, 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 decreasing. Oh, starts to increase. See how this is a point of inflection right here? Because it's changing from decreasing to increasing. So f prime decreasing to increasing, that happens at x equals 0. And then I'm increasing, 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 increasing. Oh, start to decrease. So then this point, which is at x equals 3, is my f prime increasing to decreasing. So these two are my point of inflection. All right, all values where f has a relative minimum. So I want to translate this to f prime because that's what I have a graph of. So relative minimum is f prime changes from negative to positive. So wrote my justification, and then now I just check where is it changing from. This is positive, this is negative, and then it goes to positive. So this point right here, f prime was negative and then it's positive. F prime changes from negative to positive. That happens at x equals 2. And no other points is it changing negative to positive, so I'm done there. Where is f increasing? So I know that f prime is positive is my justification. So now I look, I actually have two sections where f prime is positive. I've got this section and this section because it is literally positive values for f prime. So that's going from negative 6 to negative 2. And it's also from 2 to 3, 4, 5. D, where is f both concave up and decreasing? So let's think concave up would mean f prime. Not f prime is positive, because f prime positive means increasing, so let's go to our table. Concave up means that f prime is increasing. So that means f prime is increasing. And if f is decreasing, that means f prime is negative. So I want to know where is the graph of f prime both a negative value and increasing. So let's look. Negative value is in here, and this is decreasing, this is increasing. So this is where f prime is negative value and increasing. So that is from 0 to 2. Now E is finding f of 3. So let's think about, I want f of 3. I have a graph of f prime. So in order to go from f prime to f of 3, I need to take the antiderivative. So I want to do antiderivative of f prime. And then I'm looking for f of 3. So f of 3 is definitely going to be one of my bounds. And then it also told me in the question, it is known that f of 0 equals 4. So then now I just think, okay, I'm going to go from 0 to 3, and that will be equal to the antiderivative of f prime, which is just f at 3 minus at 0. So I said f prime, I want to get f, so antiderivative or integral, I need to go from 0 to 3 because I have 0, I want 3, and then that is the same thing as the antiderivative f evaluated at 3 minus at 0. And now f of 3 is what I'm looking for. F of 0 was just 4. And then antiderivative from 0 to 3, so that to get your antiderivative of f prime, you're just going to do the area like this. This is, oh my god, I don't know why I'm yawning so much. This is a quarter of a circle, so that's pi r squared over 4. It's only 1/4 of a circle, and the radius is 2. So that's 4, so this is just pi right here, and it's on the bottom, so I need to put a negative. And then this triangle right here is a base of 1, height of 2, so that's 2 times 1 over 2, so this is just 1. So then the area is negative pi plus 1. And to get f of 3 by itself, you need to add the 4 over. So this is negative pi plus 5. Okay, and last part, I ran out of room. Oh wait, I can just do it on the paper. All right, f, so I want to know about f prime of 3 and about f double prime of 3. So let's think about f prime. I have a graph of f prime, so if I want f prime of 3, I literally just go to the graph and look at the point. So go to f of 3, and the point is at 2. So f prime of 3 is 2, because the graph of f prime, when you're at 3, is 2. So this one, straightforward. F double prime of 3, I have a graph of f prime, so this would be the slope of f prime. And I'm looking at 3. If you look at the graph, to find the slope here, you would not be able to find the slope here because this is not differentiable. See how you have a slope of 2 right here, and then all of a sudden, instantaneously, it changes to a slope of -1? That is not differentiable, so then you would not be able to get the derivative there. So this is undefined. Explain why it does not exist, because f prime is not differentiable at x equals 3, and then we could just say like sharp turn. More formal definition would be the limit of f prime as x goes to 3 from the left is not equal to the limit of f prime as x goes to 3 from the right. But I don't think we need that. I think sharp turn is good enough for that. And algebraically, so now not looking at a graph, but at the equation. So I want to find all critical numbers. Critical numbers are when you take the derivative, set it equal to 0. So this derivative would be 8x cubed minus 32x. Yep. I'm going to set that equal to 0. I'm going to factor here. So I'm going to pull out an 8x. That will leave me with x squared minus 4. And factor one more step. All right, we find all of our critical numbers. So x equals 0, that is a factor. X equals 2 and x equals -2. All of these are critical numbers. Now, B is asking of these critical numbers, which ones are relative max or min, or neither. So let's make our f prime number line. We know 0, -2, and 2 are going to be on there. And now what we're going to do is we're just going to check at each of these, is f prime going to be positive or negative? It's easiest to do this using your factored form, because just think about if I were to plug in, let's say I plug in 1. This will be positive. 1 minus 2, that will be negative. 1 plus 2, that will be positive. So it'll be positive, positive, which is negative. Now if I go to 3, positive, 3 minus 2 is positive, positive, so this is positive. If I go to -1, that will be negative, negative, but positive here. Negative times negative is positive, so positive in there. And -3, negative, 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 that will be negative overall. So then negative to positive, this is a minimum. Positive to negative, maximum. Negative to positive, minimum. So then you have a relative minimum at x equals -2 and 2 because f prime is going from negative to positive. And we have a relative maximum at x equals 0 because f prime is going from positive to negative. Where is f increasing or decreasing? So f is increasing where f prime is positive, so -2 to 0 and x greater than 2 because f prime positive. And f is decreasing where it's negative, so less than -2 and 0 to 2 because f prime is negative. Where is f concave up or down? So that's going to be about second derivative. So take derivative of the first derivative. So that will be 24x minus 32. And I'm going to set this equal to 0. So then 24x equals 32. Divide by 8. So that would be 4/3. Okay. And then I'm like my f double prime number line, 4/3. If I plug in 0, this will be negative. If I plug in 5, this will be positive. So then I have my f prime number line. So f is concave up, or f double prime is positive, so x greater than 4/3 because f double prime positive. And then f is concave down, x less than 4/3 because f double prime is negative. And then x equals